Did evolution change our color? Close your eyes and imagine a planet. Its oceans are purple, its plants are purple, the sky's the same, but the world is completely different. It sounds like science fiction, doesn't it? But this isn't just a fantasy. It's a scientific hypothesis. The purple planet theory. Today, plants are green because they contain a pigment called chlorophyll. Chlorophyll absorbs most of the sunlight but reflects green light. That's why we see them as green. But what if chlorophyll never existed? What if another pigment had developed instead? For example, retinol. Retinol is purple in color. It absorbs green light and reflects purple. So if photosynthesis on Earth had started with retinol, today nature wouldn't look green. The interesting part is this. Retinol is a much simpler molecule compared to chlorophyll. This means it could have appeared earlier in evolution. Some scientists even suggest this. The first life forms might not have been green, they could have been purple. Even today, there are still organisms using this pigment. They live in salt lakes and extreme environments. In fact, maybe our eye structure even carries traces of this purple past. The human eye is sensitive to three main colors: red, green, and blue. But do you know where it's most sensitive? To green light. We can distinguish shades of green very clearly. But when it comes to purple, things are different. Purple is at the extreme end of the spectrum, and we don't have a dedicated receptor for it. The ability to see purple is actually due to the stimulation of both blue and red receptors together. So it's not really a true perception of purple, it's more like an optical illusion. Some scientists believe it's no coincidence. Perhaps our ancestors, living in a world full of purple organisms with retinal pigments, had eyes that focused on green to better distinguish the world around them. Over time, sensitivity to green increased, and purple was left behind. So how our eyes see today might be a silent echo of that ancient purple world. If retinol was so effective, why wasn't it the winner of history? Why did evolution favor chlorophyll? Because retinol could only absorb the green part of sunlight. It was ignoring a large portion of the energy. This meant ignoring a massive energy source. It couldn't use the red and blue light. The red and blue light from the sun would pass right by retinol. In a way, this limited its potential. And here, evolution comes into play because nature always favors efficiency. This limited energy naturally reduced the chances of survival. But then chlorophyll entered the scene. Instead of exploiting the weaknesses of retinol, chlorophyll could use a much broader spectrum of sunlight by absorbing both blue and red light. it effectively gathered a much larger portion of the sun's energy. This meant more energy, more food, and most importantly, faster growth and reproduction. In other words, chlorophyll's role in the ecosystem wasn't just to absorb light. It was providing the most efficient energy solution that evolution had to offer. This evolutionary superiority naturally led to the decline of retinal as chlorophyll gradually and steadily carved its path in nature. In the face of retinal's limited potential, the evolutionary superiority of chlorophyll became increasingly evident. And ultimately, the era of the purples faded away. A green world was born, and life began to shape itself with green light. Through this evolutionary change, chlorophyll became the foundational building block of the world. However, this does not mean that the purples have completely disappeared. On the contrary, traces of purples are still alive. This ancient biochemical solution continues to survive in nature's harshest corners. In salt lakes, volcanic springs, and the depths of the poles, purple pigments are still being used. While purples may have fallen behind chlorophyll evolutionarily, they are still managing to survive under some extreme conditions. They are a remnant of evolutionary history, but these remnants are always able to survive in tougher environments. So, in this world ruled by green, the world of purples has not truly vanished. They have simply managed to survive as the inhabitants of more specific and challenging environments. In fact, some astrobiologists are looking for traces of purple light absorption in data from distant planets' atmospheres. Because molecules that absorb purple light could be the first signs of life. If we ever find extraterrestrial life, we might not encounter a green biology but a purple one. This suggests that life in the universe may have followed a different evolutionary path beyond what we know. Maybe we are the exception in the universe. Maybe green is just the color of our story, and most of the cosmos is still living in that legendary purple of the early ages. Imagine perhaps in the future when humanity steps onto other planets, the first thing they encounter might not be an alien form but a stone covered in purple moss. This stone could be a trace of evolution still continuing on a world where purple once reigned. Maybe our green observations are just a small part of a universal story, and everything else exists in the colors of another biology we cannot see.